Welcome to a very interesting playlist in which we are taking questions from our IB students, trying to understand the different concepts where students sometimes make a mistake. Let us understand these particular concepts well enough so that we can actually score nearly perfect marks in our exams. Go through these videos and watch them. If you have suggestions and comments, please don't hesitate. Also share your questions with us so that we can share them with everybody. Let us now explore and understand clearly the concepts behind tangents from external points. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Every day I get a lot of requests from students, and normally I just solve questions and provide them with solution. But here is a very special question from one of our students. It seems that this particular question was not well understood. Because of that, she made a mistake and did not get it correct. So here is a request. I got it wrong on my test and want to see what I did wrong. I really appreciate the interest in understanding the concepts and learning from the mistakes. That is key for success. I'm happy that I can share such a question with you today, and I hope you also understand this concept and you are in a position to get it right. The question relates to a concept where a tangent is drawn from the external point. Normally, in questions which you practice, the point is on the curve and there can be only one tangent on the curve at that point. However, when we have an external point, there could be more than one tangent, right? So, in this question, we're talking about a parabola and an external point. Let's look into the question first and then we will discuss. So I have typed out this question here. It says the point 211 is external to f of x equals to 5x squared minus 2x. If f of x has two tangents that pass through 211, determine the points of contact of the tangents to f of x. Your solution must include a sketch of the function and tangents. I have extended this question to find the equation of tangents also. Okay. So this is a very beautiful question, and thanks to the teachers who have actually explicitly mentioned that there is an external point from where two tangents can be drawn on the given function. Many times this is a hidden statement, and so it becomes extremely difficult for students to answer. So in our series to clear critical concepts, here is a very important question based on calculus. Now, in case you want to learn from me, you can always send an email on the address given. Most of my students are scoring excellent marks and getting awards and scholarships like Akshat.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshat gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Now, let us try to understand the problem. It says that the function is 5x squared minus 2x, means a parabola which is opening upwards. So let me just sketch a parabola here. Okay. So that is the function. The point 211 is external, right? It is given here. And it is also given that if f of x has two tangents that pass through this point 211, determine the points of contact on the tangent to f of x. So what I'll do here is that through an external point we have tangents, so I'll just draw tangents on this, right? Let's say this is one tangent, and let me draw another tangent also. We are just understanding the concept behind. So do you see, from an external point, let's call this point as P, you are in a position to draw two tangents to the curve, right? So we need to now find these points. So let the coordinate values be, x value be A. In that case, what is going to be the y value? It will be f of A, right? So if I substitute A here, I get 5a square minus 2x. So we'll just focus on one of these points and see in our calculations, do we get the other point also, right? Okay. Now in this problem, we are given that the external point is 211. So let me write that down. So let's say this is my external point 211. It's a rough sketch. We'll find the points of contact and equations and everything later. But I hope this concept is clear, right? A parabola, external point, two tangents. Perfect. Let's call the point of contact be Q. So we are interested in finding Q at least, right? There are 2 points like this. Perfect. Now when I draw a tangent to a curve, we can always find slope of the tangent at any particular point by using the concepts of derivatives, right? So what we are going to do here is, let me list out the steps which we are going to follow. 1, we'll find the derivative of the function. Now this derivative is at any point on the function, correct? Now at point A, this derivative will be f prime A, right? Once you know the derivative, in that case, you can find equation of tangent at that point, right? So tangent will be what? Equation of tangent you can find by slope-intercept form, y minus y1 equals to m times x minus x1, correct? Now in this particular case, m is going to be the derivative at point A, and x1, y1 are going to be a and 5a square minus 2x. Makes sense, right? So we get our equation where we can actually now write down our equation in terms of, let me write down here that x1, y1 will be what? Will be, in this case, a and 5a square minus 2x. Is that clear to you? So we get our equation, perfect. And m is the derivative at a. Absolutely clear. Now in this particular equation, if I substitute a, 5a square minus 2x for x and y, in that case, how do I find the value of a? Well, key to get that point is that this tangent also passes through an external point 211. So that is key. So we'll substitute x and y values as 2 and 11. So as soon as I substitute 2 for x and 11 for y, I will be in a position to find the value of a, right? You get the idea. So that means I have solved this particular tangent. Perfect. Now in solving, I might get the other point also, which I will. That is why the question specifies that there are 2 points. You get the approach. Perfect. So as soon as I get point A, I can fill up the coordinates, which I am saying at present as Q. So let's say if there are 2 points, we'll get Q1 and Q2. So you understand the approach. Perfect. You can now pause the video and answer this question. And let's go through the solution. So I've written the question in short here, external tangent from external point P to 11 to this particular function. So as I was saying, let the point be A. So for the function f of x, which is 5x squared minus 2x, derivative is what? Derivative of this function gives us the slope at that particular point, which is 10x minus 2, right? So derivative at point A will be substitute x with A, so we get 10a minus 2. So that becomes the derivative, right? And remember what the point is? Well, if I put a, I get the y value as 5a squared minus 2a. Clear? Right. So that becomes the point. Now, if I know the slope and the point, I can use this equation y minus y1 equals to the slope or gradient x minus x1. So we have y minus y1 is 5a squared minus 2a, it should be put in brackets, equals to the gradient f of a, which is 10a minus 2 times x minus a, right? So that becomes the equation of tangent, which goes from point P to the function, right? So we are doing this part of finding any tangent's equation on this curve, general point a, 5a squared minus 2a. Perfect. Well, let's simplify this particular equation. So y equals 2. Let's take all this to the right hand side. So we get here 5a squared minus 2a, taking both of them to the right hand side. Opening with x, we have 10a minus 2 times x, and multiplying with minus a, minus 10a squared plus 2a, right? So we have y equals to minus 10a square and 5a square gives me, let's simplify this, so minus 5a square, right? And a values plus 2a minus 2a cancel, okay, so these cancel, okay. So we have the x values. Let me write like this, better write x values first. So I'll write down 10a minus 2 times x, that is the gradient now, and 5a square minus this means minus 5a square, correct? So we get equation of the tangent line, which is now equal to the gradient 10a minus 2 x minus 5a square. So the y-intercept is 5a square. You get it, right? So that becomes the equation of the line. Let me write it big and bold. So we get tangent equation at x equals to a, right, is y equals to 10a minus 2 times x minus 5a square. Perfect. So we have this tangent equation. Now what is special? This tangent passing through the point 211. If I substitute 211 for x and y, I'll get the value of a, right? So specifically, I have now worked out equation of tangent, which is also passing through the external given point 211. Perfect. So I'll write down this equation, which is 10a minus 2x, right? So let's write down, we have this equation here, y equals to 10a minus 2x 2 times x minus 5a square, correct? So that is the equation, 10a minus 2, that is the gradient, 10a minus 2, do you see that? 10a minus 2 is the gradient, and we worked out minus 5a square as our y-intercept. Perfect. Now if I substitute the given point, which is for us 2 and 11, what do I get? So I'm substituting the point P, which is 2, 11. So 11 is the y value, and we have 10a minus 2 times 2 minus 5a square. Let's expand, open the bracket, 20a minus 4 minus 5a square. So that is a quadratic equation in a squared. Do you see that? Bringing all the terms to the left side, we get 5a square positive minus 20a, right? And 11 will add 4 to it, right? Equals to 0. So we have our equation now, which is 5a square minus 20a plus 15 equals to 0. Perfect. Now this is a quadratic equation, and that is why we can get two values of a. Let's figure this out. Factor 5 first. We get a square minus, dividing 20 by 5 gives you 4a, and then 15 by 5 gives you 3. And this can be factored easily. Product of 3, sum of minus 4 means a minus 3 times a minus 1 equals to 0. Solving this, we get the answer a equals to 3 and a equals to 1. Okay? Since we get the values of a, we can actually get the f of a also, and we'll get the point. You get the idea. Perfect. Great. So we get the value of a as 3 and 1. Is this clear to you? Right. So let's move on and get the required points, because see, the question is asking for points on f of x, right? So we got the x values. We know the function f of x is basically equal to 5x squared minus 2x, and f of 1 is what? If I substitute 1, because we got the critical points, x equals to 1 and x equals to 3, where external tangent will be touching the function. So if I put 1 here, 5 times 1 square minus 2 times 1, we get what? 5 minus 2, which is 3. And so this particular point here is 1, 3. Is that clear? Let's find the other point, which is f of 3. Substituting 3, we get 5 times 3 square minus 2 times 3. And that gives you 5 times 9 minus 6, or 45 minus 6, or equal to 39. And therefore, the second point will be at 3, we get 39. Correct? So that becomes the second point on this particular parabola. Correct? So do you understand how we found the points on the curve? So basically, if I go back to our drawing, which is drawn here, we have found these 2 points, right? We have found one point here, the other one, which is 1 and 3, and the other one is 3 and 39. Makes sense? So that is how we have actually solved this particular question, where points were required to be found. Correct? So we'll actually extend this to finding equation of tangents also. So let us extend for you as an exercise. Find equation of both tangents. Perfect. Right. So what I've done here is provided you with neat and clean typed out solution. Sometimes my handwriting is not all that good. You have some difficulties in understanding. So the approach here was, we took the function 5x squared minus 2x, found the derivative, which is 10x minus 2, substituted a to find slope of gradient or gradient at a particular point a, which came to be 10a minus 2. And the value or y value will be 5a square minus 2a, and that gives you a point a, 5a square minus 2a with slope of 10a minus 2. Using slope-intercept form of the equation, we substituted the values, isolated, and wrote the equation in slope and intercept form. Perfect. Once we did that, we have to find the points. To find the points, we utilize the external point, 2, 11. So the tangents which specifically pass through 2 and 11, substituting y as 11 and 2 for x, we came up with an equation which was a quadratic equation, right, which can be factored and solved two values of a. Substituting these values of a, we get their y values or the points required. So that gave us the answer for the question, and the 2 points were 1, 3 and 339. Perfect. So then we have extended this question. Well, we did find both points. Once you have both the points, you can find the equation of tangent. Now what I did here is, since we have done the hard work of finding the points first, we already have equation of tangent, which is given to you right there, slope of 10a minus 2 and the y-intercept of minus 5a squared. In that equation, which we derived earlier, right, I substituted a as 3 and a as 1, correct? Substituting with 3 and 1. Do you see that? You derive at the equation of the tangent lines, which is y equals to 28x minus 45 and y equals to 8x minus 5. Clear? Many times in such questions, you have to find equation of tangents also. Perfect. So that brings us to the end of this particular video. And here is what we visualized. So here's the graph from the graphing calculator. The parabola is given to you, which is f of x 5x square minus 2x in red. So that is the parabola we're talking about, f of x. And on this parabola, we have external point away, and the 2 points which we are looking at are at 1, which is 3, and at 3, the value at 39, right? So those 2 points. So we have this point here, which is at 3, it is 39, and there at 1, we have 0.3, correct? And an external point. So the points are Q1 and Q2. Let's call this as Q1, right? And this as Q2. Clearly, you can see that external point gives rise to 2 tangents. And we also found their equations, which were y equals to 8x minus 5 and y equals to 28x minus 45, going through these points on the curve. Perfect. So I hope you understand and appreciate how the concept of finding equation of tangents from external point can be easily understood, right? So that is what we call clear critical concepts, so that such questions can also be solved in test papers without any difficulty. Now, in case you want to learn from me, you can always send an email on the address given. Feel free to contact, and if you like and subscribe to my videos, that would be great. Thanks for your valuable time, and all the best. Keep learning.